All right, we're going to go over segment and angle proof notes. This will probably be the most frustrating thing you've ever done before in your life. I will try to make it as easy as possible. I am so sorry. But it is a gigantic part of geometry, and we have to learn how to do it. Okay, so first of all, number one, this is our first proof here. It is a small proof. But I'm going to show you how to use your proof foldable to help you with this and the way that you would logically figure out what comes next, okay? That is the hardest part, is figuring out what comes next. First of all, always, 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 you can fill out 3 different things on any proof, no matter what you're doing. You know that the very first statement is the given statement. You know that the very last statement is your proved statement. And the reason for your very first statement is always going to be given. Always. So on this problem, it's really only missing one thing because those 3 things are given to you automatically. Now, that one thing is the thing that is most frustrating and hard to find for most students. So I made the proof foldable to help you guys. So what you want to do is look for something in the proof foldable that talks about something being between and then addition of those segments together. And this is a segment, so keep that in mind. You don't want to confuse angles and segments. So we want to find something that has to do with segments that says between and then ends up with an addition problem. So we go up here to our proof foldable, and this part up here are all the segment parts, okay? So we want to find, and what we do is we look at just this portion of it here, and we try to find the word between and then addition. So we have the word between, and then we have that addition. So what I'm going to write is, oh, I cut off the very first letter, but segment addition postulate. That's how you use your proof foldable. You look at the examples, try to find one that is like what's in your proof, and you go over to the property to write it down. So the segment addition postulate is what I would write here. All right, on our next one, we always know that our very first statement is our given statement. Our very last statement is our proved statement. And then our reason for our first statement is given. Those 3 things are automatic, so I can go ahead and fill in these 2. Angle 5 is complementary to angle 7. And that MI is perpendicular to IE. Okay, and we are given this picture. So whenever we're filling out statements, what I just showed you is how you fill out reasons. When we're figuring out statements, we use the proof foldable for this as well. So what we're going to do is find the word complementary and see what it says next. Once you know that things are complementary, what do you know next? So we're going to go up here and try and find that. Let me erase all of this stuff I did before. So complementary is here. When we know something is complementary first, what we know next is that you can then add them together and make them equal to 90. So as soon as you know they are complementary, you can add them together and make them equal to 90. So that's what we do next. We're going to add them together and set them equal to 90. So 5 is complementary to 7. That means the measure of angle 5 plus the measure of angle 7 is equal to 90. So remember that when we're just talking about names of angles, you just put the angle symbol. But when you're actually talking about numbers, like what they equal, degrees of them, when you're talking about angle measures, you have to put that M in front because that is an angle measure, okay? So at this point, you may be a little lost at what to do. So we're going to use our reasons to help us, and that says angle addition postulate. So let's go see what angle addition postulate says. We're going to come up here, and angle addition postulate is here. And it says that as soon as we know that things are going to have an angle addition postulate, you add them together, you add the two pieces together and set it equal to the whole thing. So that's what we're going to do here is we're going to add the two pieces together and set it equal to the whole thing. So the measure of angle 5 plus the measure of angle 7 is equal to the measure of angle MIE, because that's the whole thing. Okay. Then what do we do? Well, it says that we're going to substitute 2 and 3. So somehow we're going to substitute using these two sections. So what is the same that we can substitute? Well, right now, the things that are the exact same are these beginning pieces are the exact same. So if those are the same, that means these back pieces are the same. So I can say the measure of angle MIE is equal to 90 degrees. All right, so we know that this is equal to 90, and as soon as we have written it on a proof, we can mark it on our picture. Do not mark it on a picture until you have said it in your proof, ever, because you don't want to think that it's a fact before you've proven it as a fact. Now we have proven it as a fact. Complementary does not necessarily tell you all of that together. We have to prove it, okay? Then definition of a right angle. Let's see what it says. It's over here. And it says that it's a right angle if it's 90. So that also works in reverse. We're told it's 90. So now we can say that angle MIE is right. And then you see how it goes to perpendicular. So let's look at perpendicular and I'll show you why they can do that. It says that if they're perpendicular, then it's right. That also works in reverse. So if we know it's right, then we know it's perpendicular as well. So that's the way that that works. Okay. Next one. Again, automatics, right? So we know our proof statement. We'll go down here. We know our given statement goes here. And we know the reason for our given statement goes here. Every single time. So fill in those pieces. And anything that you're given, you can write on the picture. We're told that angle 5 is 47 degrees. Do not write that angle 6 is 133 degrees. We have not proved it yet. You cannot write it, okay? Cannot write it until we know. Okay, so frequently at this point, we know it's 47. What do you do next? And students are really confused. So some common things that you want to always keep in mind are what you can pull off those pictures. So remember the last time we did notes. Where is it? There it is. I told you that these things can be pulled from pictures. So if you're ever stuck, see if pulling one of these from the picture helps you. Obviously, this isn't a segment, so we would have to pull one of these. Does it look like vertical angles or does it look like angle addition? So let's go down. Oh, wait, one more. There was one more. I forgot to circle it. Where is it? I know I wrote it. Oh, there it is. There it is. Or does it look like a linear pair? Sorry. So we do have 3 of them with angles. We really only have 1 with segments. Keep that in mind, okay? See if any of these pictures look like your picture and see if you can use that information. So we're going to go back down to where we were working. Okay. This is a linear pair and we can say it, okay? So we can say that angle 5 and angle 6 are linear or are a linear pair. And it's from that picture. We can say that. Once you know they're linear, then you know they are supplementary. That's what this says. Remember, I harped on y'all about that, is that whenever you know they're linear, then you only know they're supplementary. You do not know that they're 180. So our next step is to say that they are supplementary, and that is, again, linear pair theorem. Okay, then after you know they're supplementary, so we're going to go up here and look at supplementary. What does supplementary tell us? Supplementary tells us that they now equal 180. So I can go down here and say that they equal 180. So the measure of angle 5 plus the measure of angle 6 is equal to 180 degrees. That is the definition of supplementary. Okay, then what do we do? So if you look, this is what changed. Oops, sorry, I did not mean to do that. This is what changed. So that is substitution. And we can do that because of this right here. So we substituted using steps 1, because it told us what the measure of angle 5 is, and step 4, because we put that in for the measure of angle 5 in that equation. And then after we did that, you would subtract 47 on both sides using the subtraction property of equality and get 133 degrees. All right, then we do have full proofs. It will be a while before y'all do a whole proof all on your own. We were going to baby step y'all through this, but it will happen on your test. So we have to cover it. First thing we do, list your givens. Now, you don't have to list them all first. I like to, just to make sure that I haven't forgotten anything. But you don't have to. You can put them where they logically go if you want to mention them later. So angle 1, I'm going to write it like this. Angle 1 and angle 2 are supplementary just because it takes up less room. Angle 3 and angle 4 are supplementary. And then angle 2 is congruent to angle 4. All of that is given to me. And I want to go ahead and mark, because it's not up here, that 2 and 4 are congruent because it told me so. Now my goal is to prove that 1 and 3 are also congruent. You need to keep that in mind because that's your goal. But what do we do now? Now, to prove that angles are congruent, you also want to prove that they're equal, because it's easier to do that way. So the first thing we need to do is to somehow put an equals in here. We need an equal to say that things are equal. So I'm going to use supplementary to put an equals in these things, okay? So supplementary up here tells us that they equal 180. So that's what I'm going to do. I'm going to say the measure of angle 1 plus the measure of angle 2 is equal to 180. And we do have 2 supplementary problems, so we can do them at the same time. Measure of angle 3 plus measure of angle 4 is 180. And all of that is because of the definition of supplementary angles. Okay. And then we need to deal with the 2 and 4 being congruent. We need to say that those are equal as well because we're going to use that, okay? So measure of angle 2 is equal to the measure of angle 4. And that's the definition of congruent, saying that we can go from congruent to equal and backwards, okay? So what I'm going to do now is I'm going to change one of these to be the same as the other. And it doesn't matter which one. I can change the 2 to become 4 or the 4 to become 2 using this guy. It doesn't matter which one you're going to do that to. You just pick one to do it to. So I'm going to say that 2 is 4. So measure of angle 1 plus the measure of angle 4 now is equal to 180. And I can do that using substitution from steps 2 and 3. So I'm just replacing that measure of angle 2 with the measure of angle 4. Okay. Then my goal, remember, is to say that 1 and 3 are equal. I need to somehow say that this guy and this guy are equal to the same thing. But if you look, their back halves are equal to the same thing. They currently are not both equal to the same thing, but they have the same stuff. So we need to make them equal the same thing. So to do that, we're going to subtract the measure of angle 4 on both sides in both equations. So I'm going to rewrite this guy, and I'm going to say the measure of angle 1 is equal to 180 minus the measure of angle 4. That is using the subtraction property of equality because I can subtract on both sides. And because it uses the same reason, I'm going to go ahead and do that to this guy too. So the measure of angle 3 is equal to 180 minus the measure of angle 4. Now, they are both equal to the exact same thing. They are both equal to 180 minus the measure of angle 4. So because they are both equal to the same thing, I can now say that they're equal to each other. And that is using substitution from only step 5. They're going to be equal to each other. And then anytime that they are equal, they are also congruent, using the definition of congruence. Now, I know I make this look super easy. It is not going to be that easy for you the first time you do it. I'm just saying. It takes repetition and practice, and you doing it over and over and over again. And even the problems you've already done, you need to do over and over and over again. It's just the practice next. So you need to make sure that you are working on them. Once you've done a proof correctly, do it again and again and again and again and again until you can do it without looking at the proof foldable or without getting any help. That is how you learn proofs. We are going to spend a long time on this, but it requires you to practice. Please do so.